Hello and welcome back. In the last lecture, we have implemented the algorithm for the insertion of a node at the beginning of a linked list. So now I'm going to elaborate that program to use another cases of the insertion of the node in the list. So we are having these cases. The first case we have already done insertion of node at beginning. So the second case we are going to implement is that insertion of node at the end of linked list. Third would be insertion of a node at particular location. So now let's implement for this second insertion of node at the end of a linked list. So everything is the same, but now I have to create a new function for that insertion at the end. Again, we are going to take some value, but here that would be not a simple. Up to this, it would be the same. First, we are going to uh, create a node. We have created a node. Then filling the value in created node. Okay, so now we have created a memory, and we are going to put some value in the data part of that node. So now let's see that what we try to implement over here. So let's say these are our nodes. So this is the start that is going to point to the first node, and then that would be the second node, and that is a null pointer. So in the previous case, we have created a node, and we have put it at the beginning like this. Now our job is not that simple. Now our job is to insert at the last. Means I'm going to insert the node. Okay, sorry. We are going to insert the node at the last like this. Okay, so that would be here, and that would be null. So this is our sole aim. So now how we are going to implement that? So let's take this previous scenario into the case. So like the traversal, if you remember the traversal part, in a traversal what we did, okay, in a traversal we use a PTR, a pointer, which is going to point to where start is pointing, and then we are going to increment that pointer until unless we are having a null. So now when you're going to perform this traversal, your pointer is giving you this location. Fine. So in the previous case, you are already having this start pointer. If it is if you are going to insert the node at the beginning, so you're already having that location. But now last you have to find, because we already discussed in the basic that you doesn't have anything to find the size of an list, right? So that's why you can't implement the binary search on a linked list. So that's why we have to find this location through this pointer and traversal. If you're going to traverse, you are reached at the last. So now this is the position where you want to enter this node. So the rest would be almost same. Okay, insert at the end. So you have created a node. Okay, let's take this scenario. So now let's put this node you want to insert in this red linked list. Okay, so now okay, let's take this. So this would be the node, and your pointer is pointing to here, null. So now here your this PTR, this is your PTR. Now this is going to point where PTR is pointing. where PTR is pointing, this node, newly created node is pointing to that location, right? And that PTR, what that location is, that is going to point over here. So now what would you get? You will get like this. So this is start pointer, this, and after that, that would be like this. So this is a null pointer. So this thing we are going to try to implement in this case. Okay, so let's start insert at the end. So we already put that thing. Okay, before that we are going to declare that pointer. Okay, so you can, okay, this is the C, and the declaration is at the top. Okay, so I am going to just copy the transversal code and I am going to paste over here. So here I use a pointer. The pointer is not equal to null. So then pointer, I'm going to update the pointer. So here no need to print your data. Okay, so this is a C. Okay, forward. Okay. So here only one line. If you want to omit this, so this is a comment, you can delete this. Now you are having this pointer which is pointing to the last, right? Pointer is pointing to the null. So temp next, that is equal to, not start, that is PTR. That is PTR. So now this PTR is going to point to, not to the null, to the temp. That is PTR. Simple. Okay, I hope that would be simple. Okay, insert at the end. So now at the end, okay, so at the end I want to insert 13. Okay, so let's try this program. Okay, so that is not shown. So there will be some problem. So and let's see where's the problem. So there is also here. So start pointer will start. My pointer is not now. PTR is equal to PTR next. So pointer is pointing to the null location. So this one. And next is equal to PTR. Okay, PTR is equal to temp. One PTR is equal to null. Everything seems to be fine. But here is an error. PTR next. Fine. I'm updating the pointer. Null. Null. Here's null. PTR. Okay, so this is PTR next. Pointer next is equal to temp. Okay, fine. Pointer is pointing. Pointer next is equal to temp. And that is equal to null. So PTR is certainly null. Okay, so let's something that happened over here. Pointer next is equal to null and pointer next is equal to temp. I think we are seeing myself. Okay. Yeah. Here we have done a mistake. Let me try this first. PTR next equal to null. Okay, then PTR next is equal to temp. Okay, so that, okay. So yes, so that is fine. So now, so why we are not taking up PTR directly over here? So there is a reason behind that. So let's take same example. Okay, so that would be start pointer pointing to this node. Okay, then this pointer pointing to this node. So now when we are having a null pointer over here, so actually C treated a null pointer that is pointing to, according to definition, that is pointing to the nowhere. But actually the C or C++ implementation of that null pointer is always zero address. That is a zero address. Your memory address would be in a hexadecimal, that is 0x59 something like that. Fine. So that is your hexadecimal. But now if pointer is pointing to null, that means that is pointing to the 0. Over here, if I'm going to take a PTR not equal to null, fine, so then it's going to traverse that thing. Now PTR is equal to PTR next. Now eventually our pointer is pointing to this 0 location, and there is no way to go back. There is no way to go back, means there is no way to access this memory. So that's why we are taking pointer next, means this pointer is pointing over here, it's next. It's okay, let me choose some other color. So let's suppose this is the pointer. This pointer's next pointer. So I'm scanning that in advance. So that then we are going to increment that next. That advance is null pointer. Then we are going to that pointer of a next, means that advance means this. We are going to place this. So whatever the temp we have created, so that pointer, the next pointer, this pointer's next pointer is pointing to this, and we already put that temp next is equal to null. So this would be our null. So that is pointing to practically to the 0. So let's rerun our program again, and you can see the one. Okay, let's see our main. So first we insert at the beginning 7. So first one 7, then okay, that was gone. Output gone. Fine, no problem. Okay, so that is our output. So it seems that that's not working simultaneously with my graphics. Okay, so first 7 is inserted, so there is a 7. So then insert at the beginning 1, so that's why 1 will take place the beginning, then 13 at the end, so that is 13 at the end. So that was about the insertion of a node at the last of a linked list, and in the next session we are going to learn that how to insert a node in between some nodes depending upon some condition. So thanks for watching, and hit the bell icon if you want the updated video information, and subscribe if you find the useful material in this lecture. Thank you.